and a common high-energy battery cell that will power an entire range of next-generation electrical vehicles.
General Motors just made waves in the EV world with a bold announcement: a brand new lithium-manganese-rich battery that packs 33% more energy density. It's not just a numbers game. This could mean cheaper electric vehicles, longer driving ranges, and fewer worries about charging. Coming from one of the biggest automakers, this isn't a quiet lab project. It's a shot fired in the next big battery race. Suddenly, 500-mile EVs feel a lot more real. The timing is no coincidence either, as rivals scramble to find their edge. Just like that, GM might have flipped the script on what's next for electric mobility. The breakthrough: 33% higher and better. When General Motors announced their breakthrough of achieving 33% higher energy density in batteries.
And Daisy, just quickly before we go, General Motors, apparently they've recalled all their electric cars because they don't work.
It was a big deal, not just for the company, but for the entire world of electric vehicles and portable electronics. Energy density is basically a measure of how much energy a battery can store relative to its size or weight. When you hear that GM has pushed this number up by a third, it means their batteries can hold a lot more power without getting bigger or heavier. This breakthrough is a game changer, and it's rooted in some really clever technology advances that have been years in the making.
Battery technology, but it's not all just us. So around us, we've got the testing facilities. We're also building a new manufacturing.
To understand why this is so important, think about your smartphone or electric car. One of the biggest complaints is always about battery life and charging time. If a battery can store 33% more energy in the same space, your phone can last longer between charges, or your electric vehicle can drive farther without needing a bigger, heavier battery pack. For GM, which is racing to lead the electric vehicle market, this leap in energy density means making EVs more appealing to everyday drivers and accelerating the transition away from gas-powered cars. What exactly did GM do to make this happen? It all starts with the materials inside the battery. Batteries have two main parts called electrodes, the anode and the cathode, where lithium ions shuttle back and forth to create energy. For years, most batteries have used graphite for the anode, but GM's researchers have focused on introducing silicon into the anode material. Silicon can hold many more lithium ions than graphite, which means more energy. The challenge with silicon is that it tends to expand and crack during charging cycles, which can quickly degrade the battery.
And balances the cell chemistry on a constant basis, ensuring optimum performance and charging capacity.
But GM has developed innovative ways to structure silicon at the nanoscale and combine it with protective coatings. This clever engineering keeps the silicon stable, allowing the battery to pack in more power without falling apart. On the cathode side, GM is tweaking the chemistry by mixing in different metals and designing new crystal structures. These improvements mean the cathode can hold more lithium ions and work at higher voltages, boosting the overall energy capacity of the battery. GM has also made strides in improving the electrolyte, the medium that carries ions between the electrodes, making it more durable and capable of handling those higher voltages without breaking down. This is key because a battery's lifespan and safety depend on how well the electrolyte performs under stress. Of course, these material advances wouldn't mean much if GM couldn't produce them reliably and affordably at scale. That's where cutting-edge manufacturing comes in. GM has invested in new production techniques that allow them to apply ultra-thin coatings and precisely control battery cell assembly, ensuring every battery performs consistently and safely. It's a huge challenge to move from a lab prototype to millions of batteries on the road, but GM's manufacturing innovations have made this breakthrough practical for mass production. Why does this matter beyond just making better batteries? Everything seems to be improving now. Higher energy density batteries mean lighter, smaller and cheaper power sources that can revolutionize everything from electric cars to consumer electronics and even renewable energy storage. For GM's electric vehicles, this translates directly into longer driving ranges, faster charging times, and more affordable prices, all critical factors to convince more people to switch to electric. And on a bigger scale, better batteries support cleaner energy grids by storing solar and wind power more efficiently, reducing our reliance on fossil fuels and helping combat climate change. This isn't just a win for the company, it's a win for anyone who uses technology powered by batteries. By pushing the limits of materials, science and manufacturing, GM is helping to build a future where electric vehicles and renewable energy are the norm, not the exception. It's exciting progress that's powering the shift toward a cleaner, more sustainable world. Of course, this shook up the EV industry, and some other brands have expressed differing opinions and immediate actions. The competitors. The reaction was immediate across the auto and energy world. This wasn't just another tech update or incremental upgrade. It was more like a major statement of intent. GM was basically saying, we're not just playing catch-up, we're changing the game. And whether they fully deliver on that promise or not, they've definitely managed to light a fire under the rest of the industry. Let's start with Ford, because they've been watching GM closely and clearly weren't about to sit back in silence. Charles Poon, who leads Ford's electric propulsion division, took to LinkedIn shortly after GM's announcement to reveal that Ford is working on its own version of LMR battery chemistry.
I'm Charles Poon, the Global Director of Electrified Systems Engineering at Ford, and today we're here to talk about batteries.
According to him, their team has made big strides toward a battery that's safer, more energy-dense, and cheaper to produce. He even claimed that Ford's battery could outperform current nickel-rich chemistries, which is a bold statement considering how dominant NCM batteries have been in delivering high range. But here's the thing, Ford hasn't backed up any of this with real data yet. No detailed specs, no prototypes for press to review, and no clear production timeline except a vague goal of by the end of the decade. That doesn't mean they're bluffing, but it does mean a healthy level of skepticism is warranted until we see something real. Tesla's response, or lack thereof, might seem like silence, but it's actually very on brand for them. Elon Musk talked about high manganese cathodes all the way back in 2020 during Tesla's Battery Day presentation.
The battery stuff we're going to talk about is truly revolutionary and essential to Tesla's goal.
So it's entirely possible Tesla has already been working with some version of LMR behind the scenes. Unlike Ford or GM, Tesla doesn't usually announce every internal development until it's either in a prototype vehicle or already headed for production. Instead of playing the PR game, Tesla tends to work quietly on its chemistries and then reveals them once they're proven. So while Tesla didn't issue a press release or tweet in response to GM's announcement, that doesn't mean they're behind. In fact, they might already be 1 or 2 steps ahead and simply choosing not to make a fuss. Now, zooming out a bit, the broader auto industry has had a range of reactions. Other major global automakers like Toyota, BMW, Mercedes-Benz and Volkswagen have all been chasing their own next-generation battery technologies, but they're taking a variety of approaches. BMW and Volkswagen, for example, have been exploring high silicon anodes and solid-state batteries with help from partners like QuantumScape and Solid Power. Mercedes-Benz, meanwhile, has teamed up with Factorial Energy to work on solid-state batteries that promise energy densities that far surpass what LMR can currently offer. These solid-state designs are still mostly in the prototype phase and face big manufacturing hurdles. But if they work out, they could render traditional chemistries like LMR obsolete within a decade. While GM's announcement feels like a leap forward, for some automakers it's more of a solid stepping stone than a final destination. That's because LMR is still a lithium-ion chemistry. Yes, it's improved, and yes, it's cheaper, but it's still bound by the same basic limits as all lithium-ion technologies. Energy density gains are impressive, but not infinite. Eventually, if EV makers want cars that charge in 5 minutes, go 600 miles on a single charge, and weigh less than current models, they'll need to move past lithium-ion entirely. That's where solid-state and lithium metal batteries come into play, and many automakers are betting big on that future. In the battery manufacturing world, the GM news was even more impactful. LG Energy Solution, GM's partner in this development, is positioning itself as a leader in next-gen battery tech, and the LMR breakthrough only strengthens that claim. What makes LMR so attractive to companies like LG is the use of manganese, which is far cheaper and more abundant than nickel or cobalt. By reducing dependency on those expensive and ethically problematic materials, LG and GM are aiming to lower production costs significantly. They also say the new prismatic cell format they're using for LMR batteries allows for up to 50% fewer pack parts, which means simplified design, easier manufacturing, and ultimately a faster path to scaling production. Other battery producers like CATL, Panasonic, and Samsung SDI have likely taken notice. They may not have made public statements, but in the world of advanced materials and EV tech, announcements like GM's almost always trigger a ripple effect behind closed doors. Labs get busier, engineers get new marching orders, and investment dollars start to shift around. It's a competitive space, and no one wants to get left behind, especially when a rival is promising lower costs, better performance, and broader commercial readiness within just a few years. Another reason GM's announcement hit so hard is the performance they're promising. They say their new LMR batteries could enable over 400 miles of range,
or LMR batteries, and they promise to deliver higher energy density, significantly lower costs,
even in larger vehicles like SUVs and trucks. That's a huge deal because those are the segments where EV adoption has lagged behind. Many consumers are still hesitant to switch to electric pickups or three-row SUVs because of range anxiety. If GM can truly deliver a long-range electric truck that doesn't cost an arm and a leg, that could open the door to mainstream adoption in a way that few EVs have managed so far. Ford has hinted that their LMR batteries could go even further, but again, until someone puts those cells into a working prototype, it's all just theoretical. That said, there are still some real challenges. LMR chemistries have historically suffered from issues like voltage fade and shorter cycle life. GM and LG say they've solved those problems, but until the batteries are tested under real-world conditions, high heat, fast charging, repeated deep discharges, it's hard to know for sure. These kinds of materials innovations often work great in the lab and look great on a slide deck, but turn out to have limitations once you put them in a car and drive it every day. That's why some experts are cautiously optimistic rather than outright celebratory. What's clear, though, is that GM's move has changed the conversation. Instead of everyone waiting around for solid-state batteries to arrive sometime in the 2030s, LMR offers a realistic near-term pathway to better EVs in the next few years. That's huge for the industry, because up until now, cost and range have been two of the biggest barriers to adoption. If GM can deliver even a portion of what they're promising, cheaper EVs with 400-mile range, it could force every other automaker and battery supplier to speed up their own development timelines. It raises the stakes. One thing is certain, the race to build the best, most practical, and most profitable EV battery is far from over. And thanks to GM, it just got a lot more interesting. But why is this very important in the development of EV batteries? Revolutionizing EV power. EVs are no longer just a glimpse into the future. They are very much a part of the present. But if you really stop to think about what makes an EV tick, it all comes down to one crucial component: the battery. The battery is the heart and soul of an electric vehicle. It stores all the energy that powers the car, controls how far you can drive on a single charge, how fast you can charge up, and even affects the overall weight and performance of the vehicle. That's why battery technology is such a hot topic right now, and why any breakthrough in this area can truly shake things up in the automotive world. For years, one of the biggest challenges for electric vehicles has been how to make batteries better. Better meaning more powerful, longer lasting, cheaper, and safer. The current lithium-ion batteries have done a fantastic job getting us to where we are today, but they still have some major limitations. They can take hours to charge fully, they add a lot of weight to the car, and over time their capacity tends to decrease, which means the car doesn't go as far as it used to. Plus, the cost of batteries makes EVs more expensive than traditional gas cars. All these factors have slowed down the widespread adoption of electric vehicles, especially for people who worry about long road trips or the price tag. Enter General Motors and their latest innovation in battery technology.
According to GM, the batteries use a prismatic cell format and a unique composition that completely removes cobalt.
GM has been pouring a ton of resources into developing a new kind of battery that promises to revolutionize the EV industry. If they succeed, this could mean faster charging times, longer driving ranges, and a significant drop in battery costs. Imagine being able to charge your car as quickly as you fill up a gas tank or driving hundreds of miles on a single charge without worrying about running out of power. That kind of breakthrough would be a game changer, not only for consumers, but for the entire automotive market. What makes GM's innovation so exciting is that it tackles many of the problems that have held EVs back. They are looking beyond the current technology and exploring new materials and designs that could push battery performance to new heights. This isn't just about incremental improvements, but a potential leap forward that could bring electric vehicles closer to being the go-to choice for drivers everywhere. The environmental impact alone would be huge. Cleaner transportation with less reliance on fossil fuels could drastically reduce carbon emissions and help combat climate change. When we talk about revolutionizing EV batteries, we're really talking about a fundamental shift in how electric vehicles are powered and experienced. It's about making electric cars more accessible, more convenient, and more appealing to everyday drivers. GM's efforts show how important battery technology is to the future of transportation, and their breakthrough could be the spark that accelerates the transition from gas-powered cars to electric vehicles for good. This is more than just an upgrade. It's a potential turning point for the entire industry. Understanding LMR battery technology.
Now, what makes these LMR batteries special?
There are tons of different types out there, each with their own quirks and specialties. One of the newer and increasingly popular types is called the LMR battery, which stands for lithium-manganese-rich. This type of battery is getting a lot of attention because it promises better energy storage and safer use compared to some older lithium battery versions. But what exactly is an LMR battery, and how does it work? Let's dive in and break it down in a way that makes sense, without all the complicated jargon. First off, an LMR battery is a kind of lithium-ion battery, which means it stores energy by moving lithium ions back and forth between two electrodes, a positive one called the cathode and a negative one called the anode. Lithium-ion batteries are everywhere now, powering everything from smartphones to electric cars. What makes LMR batteries different is the material used in the cathode. Instead of just using cobalt or nickel like traditional lithium-ion batteries, LMR batteries have a cathode that is rich in manganese. The rich part means there's a higher concentration of manganese in the cathode material compared to other elements. Why does manganese matter? Well, manganese is a relatively cheap and abundant metal, and it has some properties that make it very attractive for battery cathodes. It can help improve the battery's overall capacity, meaning the battery can hold more energy. Plus, manganese tends to be more stable and safer when compared to materials like cobalt, which can sometimes cause overheating or other safety issues. So the idea is that by using more manganese, manufacturers can make batteries that last longer, are safer, and cost less. Now, let's talk about how these LMR batteries actually work inside. Like other lithium-ion batteries, they operate based on the movement of lithium ions during charging and discharging. When you charge the battery, lithium ions move from the cathode to the anode, and when you use the battery, they move back from the anode to the cathode. The cathode in an LMR battery has a special crystal structure that can hold a lot of lithium ions, thanks to that manganese-rich makeup. This structure is often called a layered structure, because of how the atoms are arranged in layers that lithium ions can easily slip in and out of. One cool thing about LMR cathodes is that they have a very high capacity for lithium, which means the battery can pack in more energy than some traditional lithium-ion batteries. This translates to longer battery life, or smaller batteries, with the same energy storage, which is great for things like electric vehicles, where every bit of energy density matters. However, getting all that capacity out isn't always simple. These batteries can sometimes experience something called voltage fade over time, where the voltage drops slightly after many charging cycles. which reduces the total usable energy. Researchers are actively working on ways to reduce this effect and improve the lifespan of LMR batteries. Another thing worth mentioning is safety. Batteries can be tricky because if they get too hot or are damaged, they can sometimes catch fire or explode. LMR batteries tend to be safer because manganese-rich materials are more thermally stable, meaning they are less likely to overheat. This makes them a promising option for electric vehicles and large energy storage systems where safety is a huge concern. One challenge with LMR batteries is that making the manganese-rich cathode material in a consistent and reliable way can be tricky.
85% nickel, 10% manganese, and 5% cobalt.
The chemical reactions inside the cathode during charging and discharging are complex, and if the material isn't made just right, the battery might not perform well or last as long as it should. But thanks to ongoing advances in chemistry and manufacturing, companies are getting better and better at producing LMR batteries that meet high standards. In a nutshell, LMR batteries are a type of lithium-ion battery with a cathode that contains a lot of manganese. This gives them the potential to hold more energy, be safer, and cost less than some other types of lithium batteries. They work by moving lithium ions between the cathode and anode during charge and discharge, with the manganese-rich cathode offering a stable and high-capacity home for those lithium ions. While there are some technical challenges like voltage fade and manufacturing consistency, the future looks bright for LMR technology as a promising option for everything from electric cars to large-scale renewable energy storage. If you are curious about the future of batteries,
the new GM incentive package creates a new battery plant at the Delta Township Assembly Factory, and it designates an existing plant.
LMR technology is definitely something to keep an eye on because it blends the best of capacity, safety, and affordability. And since we all rely on batteries more and more these days, innovations like this could help make our devices last longer.
And General Motors will build its second US electric vehicle battery factory.
And our energy systems cleaner. Pretty cool, right? The bigger picture. This is not just about numbers or technical specs. It is about making EVs more practical, more fun to drive.
GM has just made a bold move in an ever-growing EV market, revealing details of an electric lineup powered by new battery technology.
And more appealing to everyday people. The improvements in battery design affect nearly every part of the driving experience, from how far you can go on a single charge to how fast you can get back on the road after plugging in. Let us break down what this means in simple terms. First and most obviously, higher energy density directly improves driving range. When a battery can store more energy in the same physical space, the car can go farther without needing a larger battery pack. That means drivers can travel longer distances on a single charge without constantly worrying about finding the next charging station. For many people, range anxiety has been one of the biggest reasons to hesitate before switching from gas to electric. With this new battery technology, GM is removing that barrier.
So what makes GM's Ultium platform stand out?
Imagine getting an extra 100 miles or more out of the same size battery just because it is more efficient. That kind of improvement opens up EV ownership to people who live in rural areas or regularly take long trips where charging options are limited. But it is not just about how far you can drive.
That translates to up to 400 miles or more on a full charge. Working together with LG Chem, GM says they expect battery cell costs.
Charging time also gets better with higher energy density. Because the battery can accept and store energy more efficiently, it means the car can recharge more quickly. With the right charging setup, these batteries can handle faster energy input without overheating or wearing down the battery cells. For drivers, this means shorter pit stops. Instead of waiting around for 45 minutes or more to charge your vehicle, you might be back on the road in 25 or 30 minutes with a significant amount of range added. That makes owning and using an EV feel a lot more like using a gas-powered car in terms of convenience and freedom. Weight is another area where the benefits really start to add up. Traditional EV batteries are heavy,
Low taxes and low regulations help us bring some of these names in, like GM, LG, and even Oracle,
which affects everything from acceleration to handling to energy use. But with this new technology from GM, you get more energy without needing to increase the size or weight of the battery. In fact, in many cases, you can keep the range the same and shrink the battery, making the car lighter overall. A lighter vehicle is not only quicker off the line, but also uses less energy to move. This boosts overall efficiency, meaning you get more miles per kilowatt hour and save even more on energy costs. Lighter vehicles also experience less wear on tires and brakes and can even be more agile and enjoyable to drive. Efficiency is the big picture here. When a car is lighter and the battery is more powerful and quicker to charge, everything just works better. It is not just about performance and range. It is about how seamlessly the car fits into your lifestyle. Whether you are commuting through traffic, running errands, or taking a road trip, your EV feels less like a compromise and more like an upgrade. Better efficiency also means that energy from charging stations and the grid is used more wisely, which helps reduce strain on the infrastructure as more people switch to electric cars.
The cells will produce 60% more energy capacity than our existing electrical battery cells.
All of these gains come from GM pushing the limits of battery science. Their engineers have refined the chemistry of the battery materials, especially the electrodes, to store more lithium ions in a more stable structure. Combined with smarter manufacturing and improved thermal management, these batteries are not just more powerful but also more reliable and longer lasting. GM's additional energy density increase is not just a lab achievement, it is a real-world improvement with huge implications. It extends the range, reduces charging times, cuts down on vehicle weight, and makes every mile driven more efficient. For drivers, that means less hassle, more freedom, and a smoother path toward adopting electric vehicles. For the industry, it is another big step toward making EVs the new normal. But will General Motors sustain their rank in the market, especially with this kind of innovation? Strategic vision and market positioning. General Motors is undergoing a transformative shift in its strategic vision and market positioning.
GM says Tennessee claims nearly 40% of the jobs in manufacturing for electric vehicles in the Southeast.
Driven by the accelerating global transition toward electric vehicles, at the core of this transformation is GM's commitment to technological innovation, particularly in battery development. With the unveiling of its next-generation Ultium battery technology, which boasts 33% higher energy density, GM is not only reaffirming its competitiveness in the electric vehicle space, but also strategically positioning itself to lead in range, performance, and cost efficiency. GM has publicly committed to an all-electric future, pledging to eliminate tailpipe emissions from all new light-duty vehicles by 2035. This ambitious goal supports the company's broader sustainability strategy and aligns with growing consumer demand, increasing regulatory pressure, and the global urgency to address climate change. To achieve this goal, GM is investing over $35 billion in electric vehicle and autonomous vehicle development through 2025. This investment clearly reflects the company's long-term commitment. Central to this electrification strategy is GM's proprietary Ultium battery platform. Designed for scalability and flexibility, the Ultium system supports a wide range of vehicle types, from compact crossovers to large trucks. This allows GM to streamline production, reduce costs, and meet diverse consumer needs more efficiently. One of GM's most critical technological advancements is the development of new battery chemistries that deliver 33% higher energy density compared to its previous generation. This improvement significantly enhances vehicle range without increasing the battery's size or weight. These two factors are crucial to electric vehicle performance, affordability, and consumer adoption. Higher energy density brings several strategic advantages. It enables GM to offer longer-range electric vehicles, directly addressing the common concern of range anxiety.
GM announces it's close to fixing two main problems with electric cars.
It also reduces overall costs, as more energy-dense batteries require fewer materials and take up less space. This contributes to savings in production, transportation, and installation, which can then be passed on to consumers. Additionally, the improved battery technology enhances platform integration and allows for more flexible vehicle design. As a result, vehicles can be lighter and more aerodynamically efficient, leading to even greater performance gains. As the electric vehicle market becomes increasingly crowded, GM is carving out a competitive position through its focus on mass market accessibility, scalability, and manufacturing efficiency. While Tesla remains a strong competitor with its brand recognition and advanced technology, GM differentiates itself with a multi-brand strategy that includes Chevrolet, GMC, Cadillac, and Buick. This approach enables GM to reach a wide range of consumers. For example, the Chevrolet Equinox EV targets value-conscious buyers with an affordable price point. The Cadillac Lyriq and Celestiq cater to the luxury market, offering premium design and advanced technology. The GMC Hummer EV is aimed at the performance and lifestyle segment. All of these models use the Ultium platform, which allows GM to deliver unique brand experiences while maintaining back-end efficiency. Using a common battery system across multiple brands and models gives GM a significant advantage over competitors with more fragmented approaches. GM's market positioning is further strengthened by strategic partnerships and investments in charging infrastructure, supply chains, and software development. Partnerships with companies like LG Energy Solution for battery production and EVgo for charging infrastructure support GM's goal of creating a comprehensive electric vehicle ecosystem.
And we manufacture those cells in-house as part of a joint venture with LG Chem.
In addition, GM's investment in vertical integration, from raw battery materials to in-house software, mirrors the successful strategies of other market leaders. This level of control allows GM to manage costs, improve quality, and accelerate innovation. First off, what do you think of the new EV system nowadays? Write your comments down below, and let's hear from you too. Don't forget to subscribe to the channel for more.